Good morning, everybody. Morning, Deborah. Okay, I'm gonna give people a couple more minutes to show up, and then we'll get started.
Good morning, Justin.
Morning, Deborah. You'll notice you're cloned in this meeting because I actually need to get my Zoom account connected to the Althea Zoom account so that I can actually start meetings.
You have two of me.
Yes.
The world should be wary.
Yes. Well, unfortunately, we can't duplicate the actual you because that would be too powerful to allow.
It's true.
Okay. I think
Do we want
that.
to do a quick introduction since it's a little bit of a cozier group here?
Yeah, I think an introduction is good. And yeah. So I'm Justin, CTO of Althea, and currently lead of Althea Peggy development.
And I'm Deborah, CEO of Althea. And if y'all want to say hi as well and kind of let me know what teams you're representing, that would be great.
Hi, I'm Sula, and I'm here just because I was interested in Peggy. I was working on interoperability stuff with altcoin.io a few years ago, and lately these days I'm working with Cosmos SDK on some projects, and just interested in Peggy development, and that's it. I'm just gonna audit the meeting. Sorry if
No, no
it's
problem.
okay.
Welcome.
Thanks a lot.
And then I think Alex Peters over here is from Conf.io, and it's been helping us for development. Um, it's pretty late for him.
Thanks,
Well, people,
Alice.
people complained a lot when I had these at 7 a.m. Pacific time, but more people showed up.
Mm.
I think I may dial it back next time. I wanted to do two in a row at 9 a.m. to see what happened, but I think I'll dial it back. Um, so if anybody else wants to introduce themselves, obviously just hop right in. In the meantime, I'm gonna go over a lot of what we've done in the last week.
Justin, Vanessa is here in Unified DAO chat room, and she is saying that she is trying to access the call, and Zoom is requesting a passcode.
Here, so give her this link because you have to use the link with the password, which is in the full info. Oh darn it! Did somebody post the link without the passcode? No, obviously some people have the link with the passcode. Or there we go. And here. And actually, let me just go ahead and this
Let me
meeting.
put this in Twitter too.
So let's see. No
Yeah, that I
passcode,
think
no
is.
waiting room. It's fine, Alex. No problem. Thanks for showing up. Um, that's annoying. Deborah, could you wait? Who didn't tweet out the complete link? Was that my fault?
No,
Did I give you the wrong link in the first place?
I'm not sure. We'll have to figure this out after
Yeah,
probably.
well, let me just go ahead and do this. Do. There
On
is
Discord.
options for this. No. Can I only do this before the meeting is started? Hello. Sorry for the trouble. We have to have a waiting
no
room
worries.
or a passcode. Let me disable the passcode.
Oh, we're starting to see folks.
There we go.
Join us.
There we go.
Thanks, everyone,
No more
for your
passcode.
patience. Yeah,
And
thank you
then
very much.
yeah. So how did the link on Twitter end up being the short link rather than the so the link on Twitter, or the link that uh the let's see.
Does Twitter
So-
shorten all links these days?
Yeah, Twitter shortened all links. I don't think they've ever done anything less. Just well, no, for a while there you actually it counted to your total character limit, but no, all the links we have. Oh, I think I see what happened here. So, in my interest to figure this out, it looks like Twitter just removed some part of the URL, the like equals sign before the password. No, there's no equal sign before the password. Anyways, I'll stop speculating and get to the meat of this. Thank you, everybody. Please share the correct link, because I'm not sure exactly how that happened, but we'll get it taken care of next time. So sorry for the trouble there. But today we have some. I guess we should let them introduce themselves, shouldn't we? If anybody wants to introduce yourself, now's the time.
Hey, I'm Brian Warner. I'm with Agoric with Vanessa.
Awesome. Thanks for being here.
Hi, I'm Vanessa at Agoric. I work with Brian.
Hey guys, Tarek here from Occlusion.
Cool. So, let's go ahead and cover. Last time around, I had a fancy PowerPoint. This time around, I was too busy this weekend writing code to actually. I got too busy trying to get something to work, is what really happened. That I did not have the opportunity to write a nice slideshow. So instead, what I will be doing is showing off here. I think this is the right tab. So instead, what I'll be doing is showing off actual code changes that we've made and going over sort of how it works. Can everybody see my screen? I've got sort of a double thing going on here where I'm recording this meeting and also trying to do it through Zoom. So I need to make sure it's working on both.
I can see it.
Cool. So specifically what we got done so we've gotten a lot done in the past 2 weeks. And I'm going to go over some of that specifically with closed pull requests. Namely, that we have gotten a lot of the Oracle so we've gotten a lot done on the Cosmos SDK side as far as functionality that we need for a final product, but is not yet integrated into a complete working flow. And what I mean by that is that we really, how should I put it? We've had the complete Ethereum contract done for a while. It's functionally complete. But while the Ethereum contract is the most sensitive part of this from a technical perspective, it is also obviously not all the code you need for a working bridge. So the other major components that we need are mostly on the on the Cosmos side, and on the relayer, or in this case, we're calling our relayer an orchestrator since it has more complete tasks, which I'll cover in a bit when I get to that. But the Cosmos module itself needs to do several things. It needs to handle Oracle attestations. So essentially, people need to be able to say, hey, I saw this happen on Ethereum. And in this case, the validators will sign off, because they're all running Ethereum full nodes in our design, and say, hey, I saw this happen. I'm sure that it actually happened. And then things sort of move forward from there. So what we have done is that we have gotten a lot of the Oracle code done, a little bit of the bootstrapping done. That's still an open pull request. And the one thing that we have gotten, so here is bootstrap observation. So what I have been working on particularly is the orchestrator, which is a binary run by all of the validators, which observes the Ethereum blockchain, performs, sort of relays events on Ethereum over to Cosmos, where the validators all test that they happen, and likewise produces validator set updates and transaction batches to ferry from Cosmos to Ethereum. As a quick note, just because it's not obvious if you're not thinking about it a significant amount of the time, oracles bring events from Ethereum to Cosmos. So that means that if you have a deposit into the Peggy Ethereum bridge contract, the bridge contract doesn't actually do anything with that deposit. It emits an event, and then that is carried over to Cosmos via the Oracle, where the Cosmos module then issues tokens. So the only case where you're ferrying events from Cosmos to Ethereum is when you are either updating the validator set or when you are generating transaction batches. And transaction batches are transactions that come out of the bridge, not that go into it. So the fee for sending transactions, for sending funds to the bridge is always, depending on how you want to define it, it's 0, because it costs exactly as much as sending an ERC20 transaction. So that quick definition is important here, because observing events is heavily focused on having the Go code on the Cosmos side to record what you have observed and act accordingly. Whereas ferrying stuff from Cosmos to Ethereum is much harder because you have to synchronize signatures and transactions across the entire flow. And this is what I just merged yesterday and finally got working yesterday, is end-to-end validator set updates. This isn't the best way to see this code. Let's go and see this code. It's in tests, test runner, source. So what this file does is that it takes our I gotta explain the test environment first. Okay, well, let's back up a little bit. We have an automated testing environment that spins up both an Ethereum chain and a Cosmos chain, either on your local machine or, either on your local machine or in CI, particularly GitHub Actions. Now, we use this for all of our development so that everybody has a standard development environment. And what you see here is that we have scripts to build a Docker container, and then scripts to actually run the chains. And what this does is that it actually goes through the entire process to bootstrap a set of validators. Let's see, where is that set of validators? Yeah, so this script actually bootstraps a set of validators locally. Those of you who are more familiar with Cosmos may know that that Cosmos doesn't like to connect. How should I put it? Cosmos doesn't allow non-routable IPs and GenTXs, and that creates a whole bootstrapping problem. So I'm particularly proud of this trick, which you can go read at your leisure. But anyways, we spin up a 3-node Cosmos testnet. a local Geth testnet. And then we deploy the Peggy Ethereum contract, and we deploy the Cosmos Peggy module. From there, we can finally get to running the test runner, which goes through the entire process of actually... So let's see, what do you need to do to relay a validator set? So in order to relay a validator set, all of the validators have to register their Ethereum keys because they need to sign the validator set with their Ethereum keys because the Ethereum contract works on Ethereum keys, not Cosmos keys. So you have to go through all of the different validators, register all of their keys. Then you have to send a validator set request, which is essentially a snapshot. It says, hey, we're going to work together to sign a message to update the validator set on Ethereum at this given block height, where this given block height is whatever block is whatever block the update request makes its way into. So once there's agreement on a block to work on, everybody gets together and the orchestrator signs off on the validator set with the Ethereum private key that everybody has registered. And for those of you watching the recording, our mysterious pause was for no reason at all. We all decided to collectively take a coffee break. Anyways, so what happens now is that everybody has to sign the validator set and submit it. And I was just going off to show this off. That inside the Cosmos module, we actually, let's see, this is in types, yes, here. Inside the Cosmos module, we have to actually validate the signature that is provided by the relayer. So this is non-trivially difficult because obviously the signature needs to be byte for byte identical, and you need to validate it across the Solidity contract, the Solidity contract's tests, the orchestrator, which is written in Rust, and the Go Ethereum module using Geth code. And they all have their little quirks that you need to line up. But once you get that working, you can move on to... Go ahead.
Sorry, is this is signature being created by the Ethereum private keys? I lost track of which.
Yes. Yeah, the signature. Okay. So yeah, this is why I'm covering this topic specifically, because this is complicated, and specifically the flow for Cosmos to Ethereum is the most complicated part of the entire bridge, because it's specifically because you have to deal with Ethereum signatures. Up here, all of the validators essentially sign their Cosmos key with an Ethereum key, and then they sign their Ethereum key with their Cosmos key when they submit it as a transaction. So
this establishes the bidirectional binding between those two identities.
Yes, and that is what update Peggy ETH address does right now. Currently, this actually uses the key holding the validator's funds, which is obviously somewhat problematic. In the future, though, we'll just update this message to allow you to submit a Cosmos key and an Ethereum key, and that way the orchestrator will take this delegated Cosmos key, which you sign once with your actual validator key, to actually send all of its normal Oracle attestation messages. So once that's all done, we can build a message for. So you're always using your Ethereum key to build a message to send to Ethereum. So anything that goes to Ethereum is signed with your Ethereum key, and then you have Ethereum signatures, which of course need an enormous amount of trouble in the Go module to validate, but are very important because you don't want an invalid signature getting into the chain. So this way, if you're an observer and you see that somebody says, hey, I signed off on this validator set update, when they send the specific Cosmos transaction that represents that, you know that the signature is valid. It's signing the checkpoint. It says it's signing. It has the nonce it says it has, etc. So we have that done. That's working. And then finally, nearly drove me insane to get it working. See this big comet. Real pain. But anyways, so once that is finally all working, it is up to the orchestrator to take all of these signatures that the validators have submitted individually, retrieve them, and parse them into the format that the contract wants. Because we submit to the Ethereum contract what is a pretty standard hex encoded signature. So it's 65 bytes. It's all the signature components appended after each other. But the Ethereum contract wants the VRS components of the signature because it actually costs a minuscule amount of gas to unpack them. So we don't do that. We have the orchestrator do it and then submit them for us. And so this was my weekend, was dealing with the exact details of ordering all of this properly. But yeah, long story short, that is the currently end-to-end working flow. It probably would have been faster to tackle deposits first, as Alex may have pointed out. But instead, we went after the hardest flow specifically so that we could get it working and make sure that everything end-to-end worked out okay. So if I scroll down here, you see we actually built all of the Rust code, we install all the JavaScript dependencies, we compile the Peggy contract, and we finally, and then we launch an Ethereum chain and a Cosmos chain. And then we finally get down to actually sending our validator set update, and you can see that it worked because the validator set nonce on the Ethereum contract is now incremented. You can run this yourself. It's Dockerized. If you take a look at the latest blog post, blog.althea.net, it only takes about 15 minutes. You just need Docker. And yeah, so that's a quick summary of where we are. It's a lot of progress because now that we have the signatures normalized, the signatures created, the workflow to submit them back and forth, we can do withdrawals from Ethereum. It's still going to be significantly more work to make the transaction batches and get them relayed, etc. But we've got all the foundations, all of the really finicky parts about making sure that the signatures are absolutely perfectly formatted is done. So I think over the next week or two, we're going to be focusing in on getting deposits working and more of the Oracle workflows. And that will have the Ethereum to Cosmos side of the bridge working. And then we finally wrap it up with the Cosmos to Ethereum, and then we're ready for our broken net, which I'm targeting for early October. So yeah, that's a general summary of where we are. I guess I should stop and show people. So if you go to Design Overview MD, you'll find a lot about how the bridge is supposed to work, detailed definitions of everything, like what I mean when I say validator set update. Particularly valset is a shortening we use very often. So when you yes, I need to go and finish this part. This isn't an open pull request. I'll get that merged later today. But to relay Ethereum to Cosmos, I'm going to go over a simple version of the that flow, which is where you send tokens to the Ethereum contract. The Ethereum contract emits a message. The orchestrator observes this message and uses their Cosmos key to submit a Cosmos transaction that that says, hey, somebody deposited X tokens into the bridge. What happens over on, so when enough of the validators have done this, tokens are minted on Cosmos, and you actually have moved across the bridge. Yeah, I just need to wrap this up. Yeah, various things about governance, orchestrator. Yeah. So, any questions or thoughts on the design?
So I can speak now. I've moved rooms. Sorry, that I couldn't introduce me in the beginning. I would like to add. So first of all, thanks Justin for doing this presentation today. I haven't prepared anything. I just wanted to add that on the side, these the Oracle implementations that was designed is already ready to consume some of the Ethereum events. It's just that not all the REST endpoints are already there, and focus was a bit different. But there are, for example, there's a little demo I did last week, which basically does the Ethereum to Cosmos workflow. It's of course not proper code or anything. It's all early MVP stage, but just sharing in this group that we are making progress on this as well. It's so it's the Ethereum to Cosmos side that is not trivial, but so there's a lot that.
Yeah, there's a lot of different components to get working.
Yeah. One PR is for the bootstrap process. That is also a big piece of work. And I don't know what the plan is, which one we want to show us next time, but there's much more already in the code than we presented today.
Yeah, there's a lot more ready in the code. They're just not quite end-to-end ready yet. Specifically, you have done a really great job getting a lot of the Cosmos side of this ready to go and ready to start really integrating and testing. I think we're going to go for the Oracle flows next because those are ready over in the Go code, and I hope to get those working end to end, and of course design a test environment. I'm a really strong believer that any code that you want to work should be tested automatically all the time, and that includes really Rube Goldberg style, very large integration tests. Something I like to do and find useful. So I think next meeting we're going to be going for having oracles working in general. So gas cost across the bridge. So let's see, 1 second. Allow me to visit Etherscan and get the current gas cost. Current gas cost is 148 GWay, so it will cost 40 cents to cross the bridge. It is 15 cents at 50 GWay, so I think that's approximately right. At 300 GWay, we're looking at 90 cents. Yes, do Cosmos validators all need to sign the transaction, or just some amount of them, like 66%? So the answer is that 66% of all validators need to sign off on a validator set update or a transaction batch before it can be ferried to Ethereum, and likewise for a deposit to Cosmos. But there's actually a slight difference here. When we say 66% of the validators, and we're talking about something that goes to Ethereum, we're talking about 66% of the validator set as of the last validator set update. Whereas when we're talking about a deposit from Ethereum to Cosmos, we're talking about 66% of the current validator set has to say that a transaction was successful. So handling nuances like that is something that we're going to have to really work hard on as we try and move to a production version. How often does the validator set get updated? So how often does this validator set get updated? Currently, the validator set is updated every time a transaction batch is varied, and can be updated separately if the bridge is not active enough. So if your bridge is moving, let's say, 100 transactions a day, it would get updated once a day for free, essentially. It gets paid for with the transaction batch. There's actually some great efficiency benefits there. Otherwise, you're going to have to pay for a validator set update whenever the powers, whenever the voting powers on Cosmos change by too large of a margin. Yeah, that's actually something of interesting debate, and that is exactly at what threshold should people trigger an update. Right now, we're thinking of something like if 1% of the power changes on the Cosmos chain, all of the orchestrators will immediately start trying to update the validator set. And if you have a sufficiently active bridge, this just isn't a problem. So let's say you're sending 2 or 3 transaction batches an hour, then you're just updating the validator set all the time. And the bridge pays for itself. But if you have, so particularly the problem is that you have, you could have really high gas fees and also nobody using the bridge. And in that case, somebody would have to altruistically pay for validator set updates, which at 150 GWay cost about $10, I think. So Brian Warner had a question. Is there a mechanism to discourage Cosmos validators from signing bad messages? Do they get slashed somehow? And the answer is that yes, we intend to implement slashing conditions where if you sign anything in the world that is not a message that you have submitted to the Cosmos blockchain with your Ethereum key, what will happen is that that validator gets slashed. And the reason for this is actually 2 or 3-fold. Let's imagine that a validator was trying to front run everybody on transaction batch fees. So when you relay a transaction batch, you get paid fees to compensate you for paying Ethereum to actually submit said batch. But the issue there is that, let's say you're the last validator. You just wait to sign, and the transaction batch is at 65%, and you're going to push it over to 66. Well, you could, instead of submitting your signature, you could keep it, hand it to your own orchestrator, and have them submit the transaction batch, because they're the only one with the signature. So we need to try and handle that problem. As well as other potential problems like submitting 2 signatures for 2 different batches with the same nonce. And right now, what has been discussed is that a good solution is just to unilaterally say any ETH key that's being used for Peggy can't be used for anything else. And that if anybody wants to submit a signature that is valid for that key, that's not some message that's already in the blockchain, they should just get slashed. This does create interesting effects with chain reorgs and such. Yes, so the October testnet, we're calling it Broken Net, specifically because we do expect it to be broken, because we are not going to be expending an enormous amount of effort to handle all of these edge cases. Instead, we want to sort of see how they work out in a testing environment. And we also want to deal with operational problems, which we might not have already observed. So I would say that Broken Net is not... Yeah, so I would say that the October testnet, which we're calling Broken Net, is not specifically for these sorts of edge cases. It is more to see that a proof of concept works and to run into really trivial problems like timeouts and batches that need to be regenerated and that sort of stuff. A real stress test is going to come in November when we've had more time to handle all the slashing conditions and edge cases.
Yeah, I would like to add as the code is very early stage, a lot of unit tests and things are missing there. So edge cases are not covered yet. So MVP is happy path. And so it would be great to see that working. And of course, operating a test net gives always insights about cases and behavior that we haven't even thought about. So that's definitely a good option. And something about the slashing I would like to add, so slashing is not even started yet. So I think the great opportunity we have is we could implement slashing on both sides. So I mean, also on the Ethereum contract, at some point we could have logic there to execute some slashing logic. So just giving the possibilities that would be doable with a bridge like Peggy. It's not, I mean, on the plan, it's not specced out, whatever, but I would like to at least inspire people to think about slashing conditions in this environment. And so that we may come up with some great solution later. So there's a ticket with some very basic and simple slashing. So slashing rules on Cosmos side only. If people have ideas, please open tickets, and so that we think more about slashing when it comes. Yeah. Okay.
Yeah, so we have sort of started planning slashing, and we're still thinking about conditions, but it's certainly none of that is currently implemented, as opposed to a lot of the other logic which has already been bootstrapped. Which already has some form of implementation that may be incomplete, but anything we've started writing, we pretty much know what the major edge cases are. Is there a group of people helping out on the Ethereum side of the bridge, or just people sending transactions over the bridge? Group of people helping out on the Ethereum side of the bridge. So there are, how should I put it? There's really only one group of people that does anything in this bridge design, and that is okay, I see you've edited it. He was saying something about slashing on ETH. Yeah. So no, there's no group of people acting on. So there's no group of people acting on the Ethereum side. You have validators. Validators run orchestrators. Orchestrators talk to the Ethereum contract. So the only people here, if you're going to think of people, are just the validators. On the other hand, slashing on ETH is, I wouldn't say on ETH is necessarily the right word. I would say that having the contract participate in certain slashing conditions is helpful. Like I said, that's all in prototype, so we're still thinking about slashing conditions. And I can't actually think of one where the Ethereum contract would need to participate off the top of my head. Alex, could you expand on that?
Yeah, sorry, I brought this topic without giving more context. We had some discussion internally, and then this comes to the fee distribution. So in the current model, which orchestrator submits the batch transaction receives the fees. But this is the current design, and but this can also go to a pool, for example, to a distribution contract that is weighted, for example. Validators or orchestrators with higher powers would receive a higher amount of the fees. For example, this is very abstract discussion now. And if money or the fees goes to a pool, then you can also take out from this pool. Just do not distribute to a validator who did bad behavior and these kind of things. This is just, let's say, the context, the discussion we had internally, but this is not the plan for the first implementation, definitely. So we want it simple, and first who first submits a batch receives the fees.
Yeah. The most recent change we've made in that nature is what I was talking about before, which is where we which is where we mandatorily bundle a validator set update with a transaction batch, because that provides a nice way to pay for validator set updates. Because normally, those are so if somebody just needs to pay for a validator set update, it pretty much has to be done altruistically. But if you force people who want to get the fees for ferrying a transaction batch to also submit an update, you end up in a situation where, as long as the bridge is active, nobody ever needs to pay anything out of pocket to keep it updated and keep it working. There's still the inactive bridge case, which I was talking about earlier, which will need some discussion and engineering. Cool. Well, if we don't have any more questions, I'll go ahead and break for the week, and we'll see you not next Monday, but next month. Oh, our good is suggest signing a liability term for intentionally. I'm afraid I don't understand. Could you expand on that a bit?
And also, we will be having a call for the broken net validators, kind of coordinate that on October the 5th. So if you are interested in being a broken net validator, there's an Airtable sign up in the chat, and we'll be talking to you next week.
Tardigrade is the Confio network. It's regulated, and I think we should keep this off topic. This does not belong to this call.
Yeah, that is off topic. Obviously, we are trying to design Peggy as a trustless system, which many people may use. Some of which may require their validators to sign legal documents. That's not relevant to running Peggy. No, there's no things. Okay, so that is a legitimate question. Peggy is a trustless system. It is a bridge where validators who are behaving maliciously will be slashed. The only condition in which your money can get stolen out of the Peggy bridge is if 66% of the validators are simultaneously malicious. And that would be roughly the same as if they wanted to rewrite the blockchain to print themselves a million tokens or anything like that. So that is the level of security we're going to provide for Peggy. It is the same level of security you would normally find on a Cosmos chain. So to be a validator on Peggy, you need the same things to be. So validators on Peggy are validators on Cosmos. So okay, I should be exceptionally clear here. When I say validators, I'm not talking about validators on any particular blockchain. I am talking about validators that are using. I'm talking about validators on a hypothetical Cosmos zone that is running the Peggy software, which we are writing, of which there could be arbitrarily many. So anybody with any zone can deploy their own version of the Peggy bridge, and the validators of that zone will be responsible for a lot of the functional tasks of keeping the bridge running. So you need roughly the same things. So the other interpretation of the question is like, what do you need in terms of physical hardware? And a validator running Peggy versus a validator just running Cosmos will need to run an Ethereum full node, and they will need to run one small binary we call the orchestrator in parallel to their actual validator node. So I don't think the extra requirements are particularly onerous, considering that many people who are running validators already have their own racks. They can just rack another machine to act as an Ethereum full node and to run the orchestrator. As a note, the orchestrator can be on a completely different machine, and once you sign, so we were talking about bootstrapping earlier. So a potential validator would need to, would an inferior subscription, okay, so I'm going to finish my thought first. Once a potential validator takes their validator keys, signs a transaction stating, "Hey, this orchestrator is working on behalf of me with with this Ethereum key and this Cosmos key." The orchestrator for Peggy can then be run on any other machine anywhere else. It doesn't even have to talk to that specific validator node ever again. So if you want to keep things very separately, like if you're concerned about having a Geth full node anywhere near an actual validator machine, you don't have to worry about that. You can sign your bootstrapping transaction offline, submit it, and your orchestrator and its Ethereum full node never need to come anywhere near your actual validator. Would an Infura subscription work in lieu of a Geth full node? Technically, yes, it would work just fine. From a security perspective, you obviously cannot have greater than 66% of the validators using Infura as a full node, or the bridge is effectively controlled by Infura. And I should make some clarifications here. Infura would not actually be able to withdraw money out of the bridge in that case, but they would be able to censor transactions and generally keep the bridge from working. So ideally, all validators will run their own independent full nodes, and I may put some stuff in the software and I may put some checks in the orchestrator software, which will cause it to simply explode and tell you to stop being dumb if you handed an Infura link, because that's insecure and it can cause problems. Especially if you're doing a testnet, though, feel free to use Infura. There's no technical problem with it. You just definitely don't want to be doing it in production. Huh. That's an interesting way. Thanks. So yeah, the orchestrator just interacts with an Ethereum RPC server. It doesn't need anything super specific. You could use Parity, you could use Geth, you could use any client you feel like. And in fact, it would probably be better for the security of the bridge if people used a variety of Ethereum clients. Well, cool. We've had some really great questions today, so thanks everybody for showing up. Reference, how to tell if a node is in... Oh, cool. I'll save that link and I'll take a look at it later. I'll actually just make an issue for it. If you want to make an issue on GitHub, you can. And I say that because I know some people like to take credit. But if you don't care, I'll do it myself. So there we go. Thank you. So yeah, I think that's everything. And thank you everybody for the excellent questions. And if anybody wants to ask more stuff, you can find me in several different Telegram channels at jkilpadr, same as my GitHub. And you can also find me on the Althea Discord and the Cosmos Discord. Just at me if you have a question, and I'll get to you as soon as I can. So thanks everybody for attending. And specifically, if you are interested in signing up for our signing up for the Broken Net Peggy testnet, see the Airtable link in the chat, and we will get in touch. So the goal for BrokenNet is that it will be broken. If you feel like waiting until we're stress testing the software and we maybe have an incentivized testnet, you're going to need to wait until November. October will be broken, and you should bring a beer so that you can sit back and enjoy us scrambling around trying to fix things. So thanks everybody for your time, and we'll see you 2 weeks from now for our next stand-up.
Thanks, y'all.